Hi and hello there. In this video, Tim and I shall explain to you what a microbial fuel cell is, its history, its usage, its pros and cons, and our conclusion regarding the microbial fuel cell. Anyways, one day we heard about them randomly and only knew that they could produce electricity, which makes microbial fuel cells fit the criteria for the chemistry project. Henceforth, we picked that as our topic and wondered the following. How do microbial fuel cells work and do they contribute to today's electricity generation? And so, we shall present to you the fruits of our labor. To start off, I'll tell you what a microbial fuel cell, or for short, MFC, in the first place is. So, first I'll take a daring guess and say that the term microbial fuel cell does not tell you a lot. After explanations, you may recognize the concept behind an MFC applied somewhere. If not, then that is fine, as you should have learned something new. A microbial fuel cell is a type of bioelectrochemical fuel cell system that generates electric current by diverting electrons produced from the microbial oxidation of reduced compounds on the anode to oxidize compounds such as oxygen on the cathode through an external electrical circuit. In the image shown on the screen, there is an MFC. On the anode, there are microbes which break down organic matter, which causes electrons to be released.
Now that you have a general idea behind the concept of microbial fuel cells, I will tell you about its history. In 1911, a professor of botany called Michael Kress Porter started research regarding this topic. Due to low current density, his work wasn't paid much attention to though. Barnett Cohen continued the research and developed microbial half cells in 1931, which could produce up to 35 volts when connected in series. Now that you have knowledge about the discovery of microbial fuel cells, I will tell you about the usage within the modern world. MFCs are used as a sort of biosensor to measure the concentration of different compounds, for example during the assessment of wastewater contamination. It can be used in the production of hydrogen or in sediment fuel cells as well.
So, first I'll tell you about the pros of microbial fuel cells and then the cons. First, there's the fact that MFCs are a renewable energy source. Next is waste treatment. MFCs can be employed for wastewater treatment. As microorganisms break down organic matter during electricity generation, it can lead to the purification of water. Next point, versatility. MFCs can potentially generate electricity from a variety of organic substrates, including wastewater, agricultural waste, and other organic byproducts. Now the last point. Remote power generation. MFCs can be used in remote locations where access to traditional power sources is limited. They could provide a sustainable energy solution for off-grid areas. Now the last upside, biodegradable components. The components used in microbial fuel cells are often biodegradable, contributing to the overall sustainability of the technology. Now onto the downsides of microbial fuel cells. First, we have a low energy density. The energy output of MFCs is currently relatively low compared to conventional energy sources, which limits their widespread adoption for large-scale power generation. Next is the slower electricity generation. The microbial processes involved in electricity generation are often slow, leading to a slow and steady production of electricity, which may not be suitable for some applications requiring rapid energy delivery. Scaling challenges. Scaling up MFCs for practical applications can be challenging. Achieving consistent and efficient performance on a larger scale may require addressing various technical and engineering challenges. Next is cost and maintenance. The initial cost of setting up MFC systems can be high, and maintenance requirements may also be a factor. Issues such as microbial contamination, membrane fouling, and electrode deterioration can affect performance. Next is a limited substrate range. The efficiency of MFCs is influenced by the type of organic substrates they can effectively utilize. Some MFCs may have limitations in terms of the range of organic materials they can convert into electricity. And the last one, technology maturity. MFC technology is still in the early stages of development, and more research is needed to optimize performance, increase efficiency, and address practical challenges before it can be widely adopted. Anyways, now's the perfect time for a segue to our conclusion.
Due to the lack of research into MFCs, they are not very efficient and therefore are not used much. Perhaps in the future more research will be conducted, leading to a possible breakthrough in MFC technologies.
So, this is the end of our video. I hope you enjoyed the video, perhaps you learned something and did not think of it as boring. Anyways, roll the credits.